Hi, I'm Mrs McTaggart and we are looking at the higher vector topic. This is lesson 2 and we're going to talk about unit vectors. So for any vector, there always exists a parallel vector, and we're going to call it u, for instance, that will have a magnitude of 1, and that means that it has a length of 1. So if you see the word if you see the word unit vector, you have to think magnitude 1. You're going to be using your magnitude formula. So for example, if we had a vector u or a to b and we're given it as abc, then the magnitude of this, so let's call it magnitude u, would simply be the square root of, let's get my pen working, it helps, of a squared plus b squared plus c squared, and whatever that answer is, it will be equal to 1, okay? Now there are three important unit vectors here, I, j and k, and if you look at them, basically they're a series of 1s and 0s. So each of these vectors would be 1 in length. So the I vector is 1, would be 1 point along the x-axis. The j vector would be 1 point along just the y-axis. And the k vector would be like 1 unit up the x-axis. So these are simply unit vectors but put onto the x, y and z directions. And any vector can now also be expressed in terms of I, j and k. So the same way we talk x, y, z, I, j and k kind of match up. So let's have a look at what I mean. So here are two vectors a and b. We're going to write them in terms of I, j, k, and it is as simple as matching up the numbers with the letters I, j and k. So vector a can be written as 3i plus 4j, and then that's negative 1. Remember, we don't put the 1 in, and then so that would just be negative k. And don't forget to underline all your little letters. So that is what vector a would look like. And vector b would just be the same, but notice there is no x coordinate, it's just 0, so you just drop the I altogether. So that would just be negative 4j and plus 7k. So this is like your I, your j and your k. And you just marry up those letters. So remember, if the one's missing, you just don't put that letter in at all. Dead simple. In reverse, they can also provide you with vectors in the I, j, k format and ask you to do something you've already been asked to do. For example, they're asking us here to add a and b. So what you can do to make life easy is feel free to always write them back out. So we've got 2i, so 2, we've got no j, and we've got minus 5 for the k. And vector b is, okay, so you've got 1i, oh, my pen's not working, 4j and negative 2k. So you can also, in reverse, put them back into component form like that. Now to find vector magnitude of a plus b, we're going to find a plus b first of all. So that would be simply just adding the two of these together. So 2 plus 1 is 3, 0 plus 4 is 4, and minus 5 minus 2 is minus 7. So to get the magnitude of a plus b, you now do the bit of Pythagoras. So it's the square root of 3 squared plus 4 squared plus negative 7 squared. Please remember, don't put that negative into your calculator if you're doing it in a calculator. So I'm going to do it without. So that would be 9 plus 25 plus 49. And if we add them all up, we get 83. Now, a lot of the times these can be expressed as surds, but 83 isn't one that simplifies at all. So you can simply take the square root of 83 or leave it as a surd. But the square root of 83 would give you 9.11 to 2 decimal places. Okay. Right, so let's get a bit more chat about this unit vector. So in this one, they've told us that negative half j plus ak is a unit vector. Calculate two possible values of a. So I am going to write this out in component form first of all. There is no I, so it's going to be 0. J is minus 1/2, and k just has an a in front of it. Now, because we're told that's a unit vector, we can put the magnitude equal to 1. So we're going to have 0 squared, I'm not going to write anything there. We'll have minus 1/2 squared plus a squared. Oh, why is my pen not working there? A squared, and we can put that all equal to 1 because it's a unit vector. We know the magnitude is 1. So let's try and simplify this down. So if you take a half minus a half and square it, a half of a half is a quarter. So we have 1/4 plus a squared equals 1. Let's get rid of that square root. So we're going to square the other side, which gives us 1 squared. We're going to take away the quarter. 1 squared is just 1, so we're going to have 1 minus a quarter, so 3/4. And the opposite of squaring is square rooting. Now, when you square root this, there are 2 possible answers. Remember, it says possible values, so plural in the question, so you're looking for 2. So the square root of that is plus or minus. Now, 4 you can square root, so we can simplify this and write it as root 3 over 2. So we could have positive root 3 over 2, or we could have negative root 3 over 2 as the 2 possible values of A. Okay, and here's another example, my last one. We've defined a unit vector that is parallel to this vector here. So if we play around with this one, let's go find the magnitude of A first of all. So the magnitude of A will be 4 squared plus negative 4 squared plus 2 squared, which gives us the square root of 16 plus 16 plus 4, which is 32, which is the square root of 36, which is just 6. So if vector A has a length of 6, we want a unit vector that's parallel but has a magnitude of 1. So literally if this one's 6 units long, we need it to be 1 unit long, so we need it to be a sixth of it. So our vector, which will be parallel, they haven't given us a letter, so I'm just going to use U for my unit vector. So vector U will be 1/6 of vector A. So it'll be 1/6 of this. Oops, wrong sign. Take away 4j plus 2k. So just to reiterate, if you are asked this question to find a unit vector parallel to another one, you find the length of that one and then literally divide your new vector by that. I can multiply this out and simplify it a little bit if you wanted. A 6 of 4 would be 4 over 6, which is 2/3. So I could say that it is 2/3 I minus 2/3 j, and 2 over 6 goes down to 1/3 plus 1/3 k. And don't forget, underline all your little vectors. So that is unit vectors. I hope this has helped. Time to go practice some. Thanks for watching.